So in this video, we are going to discuss about four type of forces, which is gravitational force, normal or reaction force, frictional force, and tensional force. Let's take a look at gravitational force first. So what is gravitational force? Gravitational force is a force of gravity that which the Earth, Moon, and other massively large object attracts another object towards itself. All objects upon Earth experience a force of gravity that is directed downward towards the center of the Earth. So we have a formula to calculate the weight of gravitational force, which is weight equal to mass multiplied by gravity. Now let's take a look at an example of gravitational force. A delivery driver is loading packages into a van. The driver first placed a box of canned goods onto a digital scale, which reached a weight of 169 newtons. So for question 1, what is the mass of this bulk of canned goods? And for question 2, the driver then adds a lighter box of pastries on top of the canned goods, and the scale now reaches a total weight of 245 newtons. What is the mass of only the box of pastries? So from the information, we know the weight of the canned goods is 169 newtons. So we assume that the acceleration due to gravity g is 9 over 8 meter over second square on Earth's surfaces. And we are going to use the formula of W equals to mg. And we are going to change a little bit. So it's going to be m equals to W divided by g. So we are looking for the mass. So we just put the information right into the formula. So m equal to 169 over 9.8. So we are going to get m equal to 20 kilogram. So the mass of the box of canned goods is 20 kilogram. So from question 2, we know that the total weight of the two boxes is 245 Newton. So basically we can find the weight of box of pastries. We just take the weight of two boxes and minus the weight of box of canned goods. So 245 Newton minus 169 Newton equal to 49 Newton. So we are going to use the same formula and we are going to change the same thing from question 1. We are going to use m equals to W divided by G. So 49 divided by 9.8. So we are going to get 5 kilogram. So the mass of the box of pastries is 5 kilogram.
Let's continue with normal or reaction force. Let's first look at the diagram. Here we have a block resting on a flat surface. There are two key vertical forces acting on the block. One is downward force labeled with W equal mg, which represents the weight of the object due to gravity. The other is the upward force labeled R, which is the normal or reaction force exerted by the surface. The normal force is basically the support force from a surface that prevents an object from falling through it. It acts when two objects are in contact, like the ground pushing back up on the block. The direction of this force is always perpendicular to the surface, so if the surface is horizontal, the normal force points straight up. The magnitude of the normal force usually equals the object's weight, mg, but only if the surface is flat and there are no other vertical forces, such as a push or pull from above or below. To explain this in terms of Newton's second law, we sum up the vertical force, sum Fy equal R minus W. If the object is not moving vertically, the net force is 0, so we get R equal W, meaning the reaction force balances out the weight. So now let's move on discussion on normal force on horizontal surface. A book with mass of 7 kg was placed on a table. Calculate the reaction force of the book.
First, we calculate the weight using W equal mg. W equals 7 times 9.81 equals to 68.67 newtons. Next, we apply Newton's second law in the vertical direction. Sum of Fy equals 0, R minus W equals 0, and R equals W. So the normal or reaction force is 68.67 newtons. Now let's look at a different situation, an inclined plane. Here, a man pushes a 20 kilogram barrel up a slope angled at 30 degrees. He applies a force of 10 newtons and the barrel moves at a constant velocity. Even though it's still a normal force, it is a bit different from the flat surface. That's because the weight is now acting diagonally and we have to break it into components. One acts down the slope and one acts into the slope, which is the part balanced by the normal force. To solve this, we first find the weight of the barrel. W equal 20 times 9.8y equals to 196.2 newtons. We take the component of the weight that is perpendicular to the slope, that is W times cosine theta equal 196.2 times cosine 30 degrees equal 169.91 newtons. So the reaction force R is 169.91 newtons. That is the force the ram applies upward, perpendicular to its surface. So now let's continue to frictional force. Friction is a resistive force that occurs when two surfaces are in contact. It acts opposite to the direction of motion or intended motion. In simpler terms, friction is what prevents objects from sliding too easily. Imagine trying to walk on ice versus on a rough road. The difference is due to friction. Friction exists at the surface level due to microscopic irregularities between the contacting surfaces. Even seemingly smooth surfaces have tiny bumps and grooves that resist movement when rubbed together. There are two main types of friction you need to know. First is static friction. This is the friction that prevents an object from moving when a force is applied. It exists before motion starts. Static friction increases with the applied force up to a certain limit. Once this limit is exceeded, the object begins to move. Second is kinetic friction. Once the object is in motion, static friction is replaced by kinetic friction. This type of friction acts during motion and it tends to have a lower value than the maximum static friction.
The general formula to calculate frictional force is F equal mu n, where F is the frictional force, mu is the coefficient of friction, and n is the normal force, which is the force perpendicular to the surface. There are two coefficients of this friction, mu s for static friction, mu k for kinetic friction. Typically, mu s is larger than mu k, which means it's harder to get something moving than to keep it moving. Direction of friction. Friction always acts in the opposite direction to the motion or the direction the object is trying to move. For example, if you push a box to the right, friction pushes it to the left. This is crucial in understanding object behavior. Friction can help us like in walking or driving, but it also can resist our efforts, like when trying to move heavy furniture.
Now, let's move on to the question. In this question, a toy car with a mass of 8 kg is pushed by a force on the rough surface. The coefficient of friction of surface is 0.32. Find the friction force of the car. For this question, I suggest we not use the summation of fx equal to ma because we are not given the acceleration of toy car, and I also suggest that we not use the summation of fx equal to 0 because we are not given the value of motion force. In order to find a frictional force, first we need to find a normal force. Now let's find a normal force by using the summation of Fy equal to 0. Then a normal force minus weight equal to 0. From then we can conclude that normal force is equal to weight. So we just use the mass of the car, which is 8, and times it with 9.81, and we will get the normal force of the car is 78.48 Newton. And then proceed to find a friction force by using the formula of F equal to mu R. where our mu is given that the coefficient of friction is 0.32 times our normal force, which is 78.48, and we will get our friction force is 25.11 Newton. Now, let's move on to the tension force. The tension force is the force that is transmitted through a string, rope, cable, or wire when it is pulled tight by force acting from opposite ends. The force is direct along string away from the body and pulls equally on the objects on the other end. So let's move on to the question. In this question, a 5 kg block is hanging at rest from the ceiling by a rope. What is the tension in the rope? Assume that gravity equals to 9.81 meter per second. So, to answer this question, first we need to look at a free body diagram. So, from this free body diagram, we can see that the tension moves to the upward, where it is opposite of the weight of the block. So, to find the tension force, we use the summation of Fy equal to 0, and then our tension minus the weight is equal to 0. From then, we can conclude that the tension is equal to weight. So, we use the mass of the block, which is 5 kg, and times it with gravity, which is 9.81, and we will get the tension force, which equal to 49.05 Newton.
So in conclusion, to understand and predict how object moves or don't move, you need to grasp 4 fundamental forces: where they come from, which way they push or pull, and how they interact. These forces are the foundation of classical mechanics and explain everything from daily events to complex engineering. So that's all from us. Thank you.